Hi, it's time for another math easy solution. Time to discuss further into improper integrals, and now go over example 10 of the example series and basically solve this example, which states use the comparison theorem, which I went over in my earlier video, to determine if the following function is convergent or divergent. And that's this integral from 1 to infinity of 1 plus e to the power negative x divided by x dx right here. So the comparison theorem here, the idea is to basically compare this integral with one that we are more familiar with, and in this case the one that's more familiar is basically the integral of just 1 divided by x. So this just, if we remove this e to the power negative x, so, and also if we recall from example 1, which I covered in my earlier video, I already went over that example. So for example 1, you can see a video link below for that. I showed that, so from example 1, integral from 1 to infinity of 1 over x dx converges. I mean, not diverges. So diverges, and you get no answer, no proper answer for that. So we'll compare this one to this function right here. So we also note that in this case 1 plus e, or I'll just go for x is greater than equal to 1. So from this interval from 1 to infinity, we have, well, 1 plus e to the power negative x all over x. Well, this is greater than 1 over x. This is the greater sign better. So this is greater than 1 over x because, well, the function e to the power negative x, that's just the same thing as writing 1 over e to the power of x. So whatever value you put, it's always going to be positive, so it's always greater than 0. So all we're doing is adding something greater than 0 to this number, to this function here. So it's always going to be bigger than this, always bigger than this. So by the comparison theorem, so if it's always bigger, then it also diverges, and I'll write that down. Thus, by the comparison theorem, thus, and you can see that in my earlier video, more on the comparison theorem. Thus, since, and I'll also graph this out so it's a bit more clear in understanding. So thus, since the integral from 1 to infinity of 1 over x dx diverges, and we also have, and 1 plus e to the power negative x all over x, it's greater than 1 over x for the domain of the, for this interval right here that we're integrating by, for x is greater than equal to 1. Thus, or then what we have is the integral from 1 to infinity of 1 plus e to the power negative x over x dx also converges. So we're basically saying this diverges, and this function here is always greater than it, then basically it also has to diverge as well. It also goes to infinity. So that is our answer. And if you were to graph these two functions, so if I were to graph this like this, x, y, so from, let's go from x equals to 1 right here. So at x equals to 1, this function here, this would be, well, this value is going to be 1 plus e to the negative 1 over 1, which just equals to 1 plus 1 over e. So this is going to be, well, greater than 1, so I'll just put it somewhere over here. I don't need to calculate it. And it goes to 0 as you go to infinity, as you put a bigger and bigger number. This is going to 0. I'll just draw it a bit further out like this. And this is the y equals 2, 1 plus e to the negative x over x function. And then if we compare it with the other function, it's going to look something like this. This one here is basically 1 over 1. And it goes something like this. So it's always, the other function is always greater than it. So it goes all the way to 0, keeps going on, and this function is y equals 1 over x. And so what we're basically saying is that this has an infinite area, so clearly this has to as well. Yeah, so if this is infinite area, then the area under this is also, then this is also infinite because it's bigger than n. So yeah, so that's pretty much the idea of the comparison. And now one more thing I just want to bring up is pretty interesting is this table here below shows computer generated values using just any computer calculator that can do this for the integral as t gets very large. So I just show this if you were to calculate these out. You would get these values, and notice how the integral does not appear to approach any fixed number. So if we have t, so again t is just from 1 to t as it gets bigger and bigger, getting close to infinity. As you can see, when it's 2 you get 0.86, when it's 5 1.82, when it's 10 is 2.52, etc. And as you keep getting larger and larger, t values is going to 9 if you were to go all the way to infinity. This number here, or it's the other way, it's going to infinity. This also goes to infinity. So it just keeps going on and on and on, and you don't have an exact answer. Anyways, that is all for today. Hopefully you learned from this pretty useful example. And like always, you can download these exact notes in the link below. And thanks for watching, and stay tuned for another Math Easy solution.